In the logical shift, what we do, like we basically shift right. I mean, if I have like, let me consider with like simplified version, like I have only 4 bit. If I shift right by 1 bit, what I do, I'll just add 1 bit and like it will become 0, 0, 0 because the 1 will go, right? This is what happened in the logical shift. If I have something like 1, 0, 0, 1, then if I logically shift right, then what will happen? It will become 0, 1, 0, 0. This is what will happen, right? But in
Yes, sir.
In arithmetic shift, we have some concept of sign. Okay, sign in the sense in the binary, if the MSB is 1, MSB means like most significant bit, that is leftmost bit. If it is 1, it is treated as negative number. Okay, it is treated as negative number. The MSB is 1, it is treated as negative number. So now, if my MSB is high, okay, if MSB is high, this example, then when I shift right, previously in the logical shift, what happened? 0, 1, 0, 0. When I shift right, now it will become 1, 1, 0, 0. So whatever the MSB is there, right, I will append to the MSB instead of 0. Getting?
Yes, sir.
If I again one more, I mean, if I shift again 1 bit by right, what it will be?
So it will be a 0, 1, 1, 0.
No. So whatever MSB is there, right, that has to be repeated. So again, it will be 1, 1, 1, 0. So if I shift again right, it will become 1, 1, 1, 1. So it will be again, if I shift, keep on shifting, it will stuck at this point only because it will be MSB will be appended with 1. But if I shift right this part, because here MSB is 0, right? This is an unsigned number. I mean, it is not negative number, it's positive number. Here, there is no difference between arithmetic shift and logical shift. This will be like again, if I shift right, 1, 0. If I again shift right, it will become 0, 0, 0, 1. If I again shift right, it will become all 0. So only when the MSB is 1, then it has to be replicated in the shift right. But if shift left, there is no concept. There is no such instruction as arithmetic shift left because the sign always we will be appending in the MSB, right? So shift left, we basically deal with the LSB, right? So there is no meaning for that. I mean, if I append 1, the value itself will be changed. So arithmetic shift right is the one instruction. Hope you got the idea.
Yes, sir.
So next is actually rotating instructions. So we have something called rotate right. Okay. So in the rotate right, what will happen? Again, see, whatever the 4 bit in the value I have given, that is not the case in ARM. ARM is a 32 bit register, right? So yes. I mean, let me consider like hope. I mean, assuming that 32 bit, but like for simplicity's sake, we will just 4 bit, okay, to understand. So rotate right, what will happen? So it is something like this. Let me write in the writing pad. So whatever the MSB bit is there, right? So that will go and sit. So after rotating right, it will become 0, 0, 1. If I again rotate right, this will go and sit here. It will become 0, 1, 1, 0. It will keep happening. So this is rotating. But in case of ARM, what it will happen? Actually, it will happen with respect to 32 bit, right? So the 31st, this is called 31st bit. This is called a 0th bit. Okay, so 0 to 31, that is 32 bit. So 31st bit will go and sit in the 0th bit. And then it is like all the other bits, we are just shifting left by 1. Got it?
Yes, sir.
Okay. So let's take one example with rotate right and ASL. So for example, if I have some bit like A, B, so this is an exam, 0x AB, F, 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 16, A, 3. Okay, this is the value in R1. Okay, this is the value in R1. So now if I say move R4, comma R2, R1, rotate right. Okay, rotate right. So rotate right with, like, maybe we can have just once, okay, once, #1. So can you tell me what will be the result in R4, final result in R4? So what, when I say A is actually 1 0 1 0, right? B is 1 0 1 1, F is 1 1 1 1 1 1. This is done. So again 1 1 1 1 1 1 1 0 1 0, 3 is 0 0 1 1. So now rotate right means actually this will go and sit here, right?
Yes, sir. So it will be 0 1 0 1 0, and at the last it
Correct.
will be 0 0 1 1.
Right.
So no,
this
0
will
1
be
1 1.
0 0 0 1 1. 0
Oh,
1 1
okay.
1. Correct.
Yes, sir.
No, 0 1 1 1. You're right. So it will become, so here 0 1 0 1. What is that value? It is 5. Correct. And this is
Yes, sir.
7. This is 7. So then it will become F. You can finish this, right? I mean, like, just in that way it will work. Hope you got the idea.
Yes, sir.
Okay. And ASR also you got, right? Arithmetic shift right. We don't have arithmetic shift left because it doesn't have any meaning as such. Okay. So we have some status flag. Next is actually we will be discussing about how to update the status flag. Okay, status flag. So we do a lot of operations, like we will I mean, in the if else statement in the C programming, you might have seen, like, we will be comparing whether is equals to B, or A greater than B, A less than B, and whenever you add A plus B, there might be some carry generated, right? Some carry generated, and like we will have like positive and negative number. So for representing all these values, like, we have status flags. Status flag. Okay, status flag register. Status flag registers. Maybe before discussing this, let me just maybe like 2-3 minutes. I will discuss like what kind of status flag we have and how we use, like when it will be set.
Okay, sir.
So the status flag what we have in ARM processor, that is called CPSR. That is, do you know the full form of it?
No, sir.
Current program status register. Current program status register. So it is also 32-bit register. 32-bit register. So the 31st bit is N, then 30th bit is Z. Each has meaning. I'll explain you what is that meaning. Then 29th bit is C, 28th bit is V, and then up to 7th bit it is reserved. Doesn't have any meaning. 27 to 8th bit, it doesn't have any meaning. Then 7th bit is I, 6th bit is F, 5th bit is T, 4th bit is M4, 3rd bit is M3, 2nd bit is M2, 1st bit is M1, 0th bit is M0. So the meaning of C is actually whenever you add two numbers, if the carry is generated by adding those two numbers, then this bit will be set. So this flag we call it as carry flag. During, I mean, any, hope you understand like what is carry, right?
Yes, sir.
Okay. While subtraction or addition, whenever you get the result as you will, in the result you get the carry, so this bit will be set. And this bit we call it as 0 bit, 0. So whenever you perform some operation, arithmetic or logical operation, if the output result is 0, then this bit will be set. That is 0 flag. Okay.
Yes. So the what do the N and V stand for?
Yes, I'll. So N actually stands for negative flag. So whenever you subtract, for instance, when you subtract two numbers, so when you subtract two numbers, if the resultant is negative, then this N negative flag will be set. Whenever the result is negative, so this negative flag will be set. And this V flag, we know how many bits we have actually in the ARM register. It is 32 bit. So when you add two numbers, if the result is more than 32 bit, then we cannot represent in any register, right? We cannot store that number in any register because all our ARM processor registers are 32 bit. I mean, especially the series what we have chosen for the discussion. In that it is 32 bit. We do have like 64 bit, 128 bit. So in that scenario, if the result is more than the bit size of the ARM register, then this V flag, that is overflow flag, will be set. Overflow flag will be set. Hope this many flags are clear to you.
Yes, sir.
So we had seen there are modes of instruction, right? Thumb mode and arm mode. Thumb mode is something like 16-bit mode. In the initial discussion, we saw like what kind of instruction modes are. So if this is set to 1, then instruction set what we are using is thumb instruction set. Thumb instruction. Else it will be arm instructions. Clear?
Yes, sir.
And this I and F. So there is one is IRQ interrupt and another is fast interrupts actually. So FIQ interrupts. So these are used to enable those interrupts. Hope you know that what is the meaning of interrupt. So like for instance, like if your processor is doing some process, so if some external signal, for example, let me consider an example of your airbag. So your processor, the microprocessor or ARM processor will be doing some engine operations or like infotainment operations or like speed measurement operations, so on. But suddenly accident happens. So in that scenario, it has to stop all other operation and it has to focus on your airbag opening application, right? So for that purpose, like we will have something like interrupt condition. So interrupt, whenever interrupt occurs, so it will stop all other functions and it will prioritize which is the emergency task has to be done. That is like now I have to activate like whatever the function required to open the airbag. So for that purpose, we do use interrupt. So I and F are interrupts. Okay.
Got it, sir.
And M for this bits, right? So this is actually, we will have like various operating modes of the CPU. So this actually sets the operating mode of CPU. Okay. Clear?
Yes, sir.
Okay. So whenever you do some operation, right? If you want to, so like generally, whenever you perform some operation, move R1, R2, if you do some this operation like this, generally it might not update the status flag. But whenever you include something like move status flag. Okay, so R0 comma hash 0. So here, can you tell me which flag will be indicated updated? So 0 flag will be updated. So here move yes means we have to move this 0 to R0 by updating the status flag. So here, I mean, if this number was negative, negative flag would have. If number is 0, since 0, now 0 flag will be set.
So if the number is positive, then which flag will be updated?
No flag will be updated. I mean, positive is actually generally it's understood. So if it is negative only, it is false issue for us. I mean,
Okay.
we have to handle carefully. Okay.
Yes.
Hope so far you are clear with this.
Yes, sir.
Next is conditional execution. So in the C programming, we perform some operation like if A equals to B or A not equals to B. So some logical output you are going to get either high or low, right? So if this condition occurs, perform some operation. These kind of conditions you write in C programming, right? Same way, we have conditional operations in ARM also, the ARM assembly level programming. Okay, so if you want to execute certain operation, okay, I mean based on some condition, then we append like suffix that move instruction with condition. Okay, with condition. So here we have option to append condition. So I'll tell you what all the different conditions are available. So like let me consider move condition R0 comma hash 10. So it means if this condition, any of the condition is passed, then only this R0, the 10 will be moved to R0, something like this. So I can give you one, like I'll tell you first, I'll tell you what are all the possible values for this condition. We have equal. So this is something like if Z is 1, 0 flag is 1. Okay, you know, Z, now you understand, right? What is Z equals to 1? It means actually 0 flag is set, then only this 10 will be moved to R0. I mean, if I say,
yes, sir,
move equal R0 comma hash 10, that means if this 10 is set, I mean, if this 0 flag is set, then this value will be moved to R0. Another is not equals to NE. If 0 flag is 0, then only this will be appended. Move NE R0 comma hash 10. Similarly, we have conditions like CS. That means if carry flag is set, then only perform that operation. CC. If carry flag is C is 0, then only perform that operation. Then MI. That is actually if the number is negative, then only perform this operation. So when I say that statement, can you tell me which flag I have to look into? When the number
so
is
the
negative.
N flag.
Very good. So N flag we have to look. If N equals to 1, then only move that number. So minus. It is actually MI means minus. Next is PL. That means plus. If the N are positive. So if N flag is 0, then only. So these are the conditional statements. Okay.
Yes, sir.
So we will take some examples. You have to tell what is the status of conditional flag and what will be the result. Okay? So we will take some code snippet examples. So what will happen here? Move yes, comma R0 comma hash 0. What will happen here? Yes.
I said the contents of 0 would be moved to R0.
Correct. R0, now R0 will become 0. That I agree. R0 will become now 0. But one more thing will happen when we add yes. Status flag also will be updated, right?
So, but then this is a pause. Oh, the Z flag will be updated. Yeah, okay.
Right. The Z flag will become 1. Correct?
Yeah.
So
Yes,
now
sir.
next condition I will say, I mean, this is like same set of program. If you say that like this is line 1, I'll say line 2, I will write move equal R0, comma hash 10. What will happen here? Whether R0 will be moved, the 10 value will be moved to R0.
So it will be moved, but the status flag will be updated as 1.
No, actually, if Z equals to 1, then only move. That is the condition, right? When we say move equals to, this is a conditional statement.
Yeah, sir, but then like the 0 flag will be updated and it will be 1. So
No, 0 flag already it is updated, right? Due to
yes.
line 1, 0 flag is updated. So now equal condition satisfies. So now R0 is updated with what? Hash 10.
A 10, sir. Yeah.
Correct?
Yes, sir.
So finally R0 will be 10. Correct?
Yes, sir.
And in this case, like if I don't have this yes, what will happen? 0 flag will be 0, right? R0 will be updated
Yeah.
with 0, but 0 flag will be 0 because I didn't put move yes. So what will happen? Move equals to will condition will not satisfy. Finally, R0 will be 0 only. Agree?
Yes, sir. Got it, sir.
Okay. Next, we have to look into arithmetic instruction. Okay. So in arithmetic, we have add.
So the rotation part.
We saw, right? Rotate right. ROR.
Oh yeah, sir. Yeah, okay.
Rotation instruction.
So
Rotation
like
right.
we didn't solve much sums on that. Like we were back to this move thing. So like I just felt like we skipped it. Or I thought it would be
Okay.
a lot more huger than just that much. So
No. Here rotation right is simple rotation. No
so that's
multiplication
all,
and
no,
addition.
sir. Rotate.
Yes. Rotate right only.
Okay. Then fine.
I mean, in the class or like some question paper, if they have given any sums, you please share to me. We can discuss on that.
Yes, sir.
So here we have add, subtract, reverse subtract, RSP. Okay. So add register, that is actually destination register. And I mean, in the sense like where we have to store the value. Same way we have register, comma, what value you want to add. So this is actually where you want to store the result. And another register plus what you want to add. Like either it can be register, another register, or immediate value like #10, #20, like that. So it can be register plus register or register plus number. Same way for this also. Subtract or reverse subtract. Subtract is A minus B, reverse subtract is B minus C, something like that. Okay.
Yes, sir.
Okay. So here also, if you just add, if there is any carry, your status flag will not be updated. You have to put a suffix of add, and can you tell me, can you guess what I have to put if you want to update the status flag? Yes,
So
add s.
the
Add s. Move yes means actually it will update the status flag, right?
so
Same
then
way,
sub S means it will update the status flag of subtract.
right. Sub s,
Okay.
RSPS. Everywhere, if you put yes, right, it will update. Okay.
Got it, sir.
So here add s, if I say add s R2, R3, R4, basically it means I have to store the result in R2, nothing but R3 plus R4. And if there is any carry bit or 0 bit, it will update. Result is negative, it will update. Okay, all the flags will be updated. And whenever we do addition, there are many flags, right? Here only 0 flag. Whenever we move also we can have, but carry flag cannot be updated. Only like negative, 0, or negative and 0 can be updated. Here also, here actually we can update negative, 0, overflow, right? Also we can update carry also. Carry, negative, 0, overflow, correct? These many flags we can update. Okay.
Yes, sir.
Along with this instruction, we also have ADC. That means add with carry. So here it was like R2 and R3 plus R4 plus, if in the ADC what will happen, add with carry. If whatever the carry flag will be there, right? That also will be added here in the add with carry. Did you get it or like confusion?
No, sir. I was just like analyzing it. That's all. Yeah, I got it, sir.
R3 plus R4 plus carry. Because generally what we do, whenever we want to add, like if I have 56 and 98, if I split these numbers, 6 plus 8, 14, 1 carry will be there. So this kind of conditions will occur, right? For that purpose, we have
Yes, sir.
to include this.
Okay.
The same way, we have subtract with carry. That is sub. Okay, we generally sub is there. Subtract with carry is SUC. Okay. Similarly, reverse subtraction with carry, RUC. RS, reverse subtraction with carry. Okay.
Got it.
Okay. So today we will pause here. So tomorrow we will see some problems in exercises on this. Like we will take some.
So based on this add SUC, RSC, and
yes, on this itself we will, and I'll include some move, equal, all these things. We will create some bigger programs.
Yes, sir.
Okay. Tomorrow at what time you will be available?
Sir, anytime after 6.
Okay, sure. So then tomorrow we will plan.
So no. Tomorrow is Saturday. Okay. Yes, sir. Around 8 to 9. Is that okay?
Okay, sure.
Sir, instead of 8 to 9, can I take it in the morning, like 9?
Morning, I have actually some workshops to take tomorrow.
So when is the workshop ending?
From 9. Actually, I start from 9. Usually, I don't take any sessions before 9. So start from 9. It will go up to 12, 12:30. After that, I have some meetings also. Post that.
Sir, around evening 4 to 5.
Sure, I'll plan.
Okay, sir. Yeah.
Okay, thanks.
Okay, thank
you.
So
this also I'll upload in the same link, whatever I shared. That.
Yes, sir. Yeah.
You can share to your friends also. if anyone want to see this arm and
Yes, sir, I will.
thanks.
Yeah, thank you, sir.